This video will show how to execute and review results for Plane Resonance Analyzer. This feature is a licensed extension of Altium Designer with paid version. It must be used in an environment where Altium Designer is installed. Please be sure to use it on a Windows PC with Microsoft Excel installed. To perform plane resonance analysis, open the Plane Resonance Analysis dialog box first. Click Plane Resonance Analysis menu and select Plane Resonance Analysis. The Plane Resonance Analysis dialog box will open. Select the plane to analyze. Here, we will analyze the 3v3_ft plane on layer 3. Click 3v3_ft plane on layer 3. If you can't select the power plane, turn on the layer with the power plane in the layer display settings. Next, specify the reference plane. Here, the GND plane to be used for reference on layer 2, so enter settings as follows. Next, set the location of excitation point to be placed between the power and ground plane. The default location of the excitation point is defined at the lower left corner on the power plane, but you can change the excitation point's location manually. Select Manual from the pull-down box and click the Select button. In Manual Settings, the power pin locations for each IC and the lower left location on the power plane are displayed in a list of excitation points as default. To add an excitation point, left-click the Layout screen. To delete an excitation point, select it from the list and click the Delete One button. Once you have completed the excitation point settings, click the OK button. Settings such as mesh size, analysis model file specification and analysis frequency can be set in the Plane Resonance option dialog box. You can adjust settings in the option dialog box as follows. Click Option in the Resonance Analysis dialog box. Specify the mesh size. Here, we will set 50 mil, the default value, in the interest of analysis time and accuracy. Specify analysis model file name and specify the file to include the capacitor analysis model specified in component property. To run plane resonance analysis, click Run in the Resonance Analysis dialog box. When analysis begins, the following progress bar will appear. When plane resonance analysis ends normally, the View Resonance dialog box opens and the maximum voltage distribution appears as a color gradation on the main screen. The red areas of the color gradation have the highest risk of resonance, and colors closer to blue indicate lower risk of resonance. You can view the maximum voltage level for each frequency on the spectrum chart by clicking VF Graph in the View Resonance dialog box. Voltage on the power plane is halved at -6 dB in relation to noise, applied voltage, and with the margin of error added, we arrive at a maximum voltage recommendation of -10 dB for the spectrum chart. In the analysis results for this sample data, the peak at 870 MHz exceeds -10 dB, leading to the conclusion that countermeasures are necessary. In addition, the voltage distribution display at this frequency shows the highest voltage in two areas in the lower left corner. In other words, there is significant amplitude and resonance. To reduce the resonance generated between planes, we will place a capacitor at the resonance antinode. The lower left corner of the screen is the reddest in this case, so we will place a capacitor there. We will use C104, which is 0.1 microfarad capacitor. Resonance analysis result information can be generated as a report by the Report Output function. Specify the frequency information for color gradation view. Click Report in the dialog. The report is generated and displayed in Excel format. Resonance analysis results such as analysis conditions, spectrum chart and voltage distribution color gradation maps are reported collectively. The report can be used as evidence of design review. In this video, we showed how to execute and review results for Plane Resonance Analyzer. EMIStream Plane Resonance Analyzer optimizes capacitor arrangement by visualizing power-ground resonance behavior. Try it as an EMI countermeasure for PCBs. For more details or inquiries about the software, please visit the EMIstream website.